Hello, everyone. Thanks for tuning into our webinar about leveraging machine learning for fuel optimization and emission compliance. Our sponsors today are global technology software and engineering firm Emerson. We welcome our guest speakers, Naveen Hegde, Senior Manager of Propulsion Control and Optimization for Emerson, and Lars Stoustrup, CTO of Frugal Technologies, who will both lead a presentation and answer your questions, which you can type in the Q&A section. Here's Digital Ship's Carl Jeffrey to start the talk.
So we're going to talk today about better ways to use machine learning for fuel optimization and emission compliance with Emerson and Frugal Technologies. We've got a technology story today about how we can use AI to work out the most efficient rotations per minute for the ship engine by building a better ship hydrodynamic model on the cloud using control technology. And we've got a commercial technology about how Emerson is supporting the maritime industry to improve emissions. So for the technology story, we commonly hear that engines run more efficiently at different revs per minute, but it isn't clear what exactly the best RPM is. This system will find it for you. Then you can adjust the RPM and so the propulsion power to optimize fuel consumption while still meeting charter party requirements. This technology is developed by Frugal Technologies. They're based in Aalborg in northern Denmark. Uni Tankers saw a 12% fuel reduction using the technology on its chemical tanker Enderlo Swan, and Christiana Shipping saw an 8 to 12% fuel reduction using the technology on tankers Jette Teresa and Alice Teresa. The process is called model predictive control. And the commercial story we're going to tell today is about Emerson. They're an automation company, one of the 100 largest companies in the US, making a strategic investment in Frugal Technologies. Emerson already does a lot in shipping, including providing cargo and bunker tank management systems, fuel flow meters, valve remote control and propulsion control systems. It's got a worldwide service network to support its shipping company customers. Now it's adding emission support to its services with a service they call SmartPropulsion, and that will incorporate the Frugal technology. So we'll start the webinar today with a 10-minute talk from Naveen Hegde, Senior Manager, Propulsion Control and Optimization for Marine Solutions with Emerson. He's joining us from Singapore, giving us Emerson's perspective. Naveen is a former onboard operations engineer with Anglo-Eastern Ship Management. He came ashore in 2011, and he's been with Emerson for 12 years. Then we'll have a 20-minute talk from Lars Stoustrup, CTO and co-founder of Frugal Technologies. He's got a background in digital control systems and cybersecurity, and he's going to explain the technology and the benefits the customers are seeing. You can put your questions in the Q&A box at any time, but we'll take them at the end. And I'd like to invite Naveen to start his talk.
Thank you so much, Carl. Thank you, Lars. Thank you, Carl, and delighted to be on board. Firstly, good morning, good afternoon, and good evening to all who are joining from different parts of the world. I'm Naveen, and I'm basically responsible for the propulsion control and optimization product group globally for Emerson. And I'll be sharing my thoughts around leveraging machine learning for fuel optimization and emission compliance. Last, we can move to the next one. Okay. Let me begin by laying the ground for our discussion. We know that reducing the fuel cost, cutting emission, and digitization will be the key trend in the marine market in the next few years. Trend one is high fuel cost, which impacts the day-to-day OPEX for a shipping company. Increasing the voyage cost due to the fuel price impacts the bottom line. So adoption of eco-friendly fuel is still expensive, and uncertainty in large-scale adoption is also not very clear. So there is a little bit of a dilemma over there. When we talk about the trend two, which you see on the right side, is around decarbonization. So over here, we are seeing new regulations are coming up. The existing regulations are becoming more stringent. We've seen with MEPC recently, who have a new target to achieve net zero by 2050. So the vessel which is in compliance today might not comply next year due to the CII limitation. The compliance will not happen by itself, and tremendous effort by the marine stakeholders is required so that all the marine industry can meet the emission targets which has been set. And the third trend, which we see at the bottom, is all about technology adoption within the marine space. As per the report, the average number of startups in digital maritime engineering has increased by almost 4.7 times since 2011. So the startups, which we are talking about here, ranges from fleet performance, which we've seen globally. It also includes some of the smart devices, which are also having some play over here. And why not? Because this is an industry where there is a huge possibilities of leveraging data. Let me take the story further with my second slide. Yeah. So if you can see, there are plenty of options which are currently available to improve the fuel efficiency and compliance with regulation. There are many energy saving options which are available, which promises saving from 2% to up to 20%. So now my question to the audience over here is, how many of these technologies can be adopted without having a dry dock? This is something to think about. Do we want the ships to wait for the dry dock before they can meet their compliance target? The next possible option, which you can see on the right side, is reduction of the speed. So slow steaming is an easy alternative. However, it is also not free. We've seen some of these publicly available report clearly mentions the possible top line impact by reducing the speed. So for a vessel to convert from an existing CII rating of E to C, top line impact could be as much as from 0.5 million to up to 1 million. And this can be higher for bigger vessel. And we all know that the vessel operating at a lower are not efficient in terms of specific fuel oil consumption. And also the impact vessel, and it also impacts the vessel health. This leads to my second question. How can we make sure that our vessels are operating at optimum speed so that there is no impact on the top line for a shipping company? And also the health of the engine is not compromised. Let us share how we can have, and in the following slides, we will share how we have tried to answer these questions. So last, if we can request to move to the next one. Yeah. So as a stakeholder for close to 50 years in the maritime space, Emerson has been committed to serving the industry to meet its goal. With micromotion Coriolis technology, with Aventics propulsion control system, we are able to provide the data to users, which can be leveraged to make meaningful decisions. And as Carl mentioned, the team is there to support globally in terms of service and also the project. But we also realized that we needed to expand our portfolio so that closed loop technology can readily benefit our users. And this is where we have done a strategic investment in Frugal Technologies, and a partnership has been forged. The product, SmartPropulsion, which you will hear in more detail, boasts about 4 key things. The point number 1 is that it is a proven technology to reduce the fuel consumption by up to almost 15%, which also means significant reduction in the emission and meeting our compliance target. My second point is around the cost of implementation, which is one of the lowest in the industry when you compare with other emission saving technology. What we've heard, some of the emission saving technology, it can go up to a few millions to implement, but the cost over here is far lower than what we've seen in the industry. The third point is around the ROI. So once we invest something, we also expect an ROI to come soon. And with this technology, we've seen that the ROI is within few months. And lastly, but an important one, is the installation time is minimal. So over here, we are looking at no dry dock or off-hire days which are required. So just imagine, you can take a decision now to install the system and start reaping the benefit before your summer vacation starts. So that more or less covers the initial pitch from my side. But before passing to Lars, I just want to have a say that fuel saving and compliance, which we are talking about here, is not a switch which can be turned on instantly. But with smart propulsion, definitely the path becomes easier. Thank you for listening, and over to you, Lars.
Thank you, Naveen. You're absolutely right. It's not shake and bake in many cases, but we do try to help. So one of the first things you have to consider when you're moving into something like smart propulsion is what has been considered in many areas before, back in the initial days of the onshore BI days, business intelligence days. Collecting data became a big thing. It was the same questions arose about what to do with those data, and how do you turn data into actual value that you can see on your bottom line. This is basically the same situation that we're in now for the maritime sector. How do you turn data into something that you can actually see on the bottom line? It's harder in our area because of the whole variability we get from weather and waves, currents, and all that. All those things that influence vessel operation are hard to take into account. It's much easier if you just have a factory, but it's not like it's impossible. But you do need to consider quite a few things, and there's some things you need to do. So first off, you want to figure out, let's look at the bottom step here of this staircase that we're looking at here. So you want to figure out which data points do you actually need. You don't need everything. It's not like hundreds of data points are necessary, but you do need some that are key to what you're actually looking for. So in this particular case, we're looking at shaft power and fuel consumption, and we want to look at the engine health parameters and things like that. And then you also want to consider, well, how often do you actually need this data? Some suggest that it's impossible to do optimization based on just noon reports, and to some extent that's true. There are things you can do with noon reports. But if you want to know about the detailed performance characteristics of your engine and hull performance in general, you need more. So do you need to sample data every second, or is that necessary? Well, for our purposes, every minute seems to be a good place, but it's something you need to consider, the time series compression of the data that you are looking at. Also, because in the end, you'll need to put that data somewhere. In our solution, we end up storing the data in a cloud solution, and it takes up space. And you need to consider how much space. Is it feasible to actually mine the data if there's too much of it? What do you do about that? So all that needs to be considered. And then one of the things that really becomes interesting is, well, then you have a lot of data, and then what? How do you ensure the quality of it? And that's one of the areas that we've been doing a lot of digging at. We have three experts who are basically only concerning themselves with how to clean up data and make it useful in model building. And some of the stuff that we do now is using NVIDIA technology, which seems to be what everybody's using these days, given the stock prices, to filter all the data and to remove anomalous, spurious errors from sensors, and to also clean up the data when it comes to trying to subtract weather information. We can actually do that as well. And then once we've done that, we're able to build models that we can actually query for information that we want. Best ways of running the engine, best ways of best choice of speed for a particular voyage, things like that. And then you want to use that as an input to change your actual operational pattern. That's the end of it. You want to actually make something of the data that changes something that in the end makes a difference. So that's sort of the abstract flow of things for basically any solution that consumes data. So looking at some of the UI or the user interfaces that we're presenting to the operations departments that have our vessels running Frugal Propulsion, we can see this is one of the things that we show off, which is the anomaly detection feature that we actually make public also, so we can see, well, which sensors on a particular vessel are doing well, which are not. Do we have to do something to actually fix the input, because the data quality is only as good as the input in the very end. So it's important to show off which areas might need a bit of work to improve the quality. And then understanding the correlation between the different data points that you have is also a very good way of figuring out whether you actually have anomalies or not. So you know, for instance, that your shaft output power, if that's one of the things you're looking at, is tightly correlated with the fuel consumption. So if one of those values seems to run off into the weeds, well, that's easy to tell if you look at the correlation between those values. Same goes for the speed and the output power, for instance. So all those things can be leveraged to better understand whether or not you're looking at valid data or not. And then one of the things that's very interesting to look at as well is also filtering out the weather data. This is something that we've moved into just recently, but we're having good success using the same sort of tools to actually subtract weather from the data that we're seeing, so that we have a much larger pool of data to do optimizations from. Because classically, you would otherwise be basically ignoring data that's too influenced by weather or waves or currents and all that. But it's actually possible to just subtract those effects and then have a nice clean signal, so to speak, that you can work with in a model. And then building models. That's the next part. If you have nice, clean data, you have the raw material that you actually need to build models. For instance, in this case, we're looking at a model of the main engine on a particular vessel, which we've anonymized here. But what we see here is that we have a model which is trained on some set of older data. In this case, it's actually data that's from about 3 months after a yard stay. So we are looking at a model that's been trained to understand what the engine should perform like in a good state. And then a while later, we see a trend in fuel consumption that's going up, which is also kind of expected. You see fouling of the engine, and you know that the turbocharger will become fouled as well, and you know that there will be an increase in fuel consumption. But exactly how much? Well, we can actually tell quite accurately here that we are looking at an increase in overconsumption at this point, which is quite significant, of 6.2 kilos per day, and a total overconsumption of 48 kilos per hour. And that in turn turns into a savings potential of $1,000 a day for this vessel. This is a bigger vessel. That would come simply from overhauling the engine. So it seems to be a good time to maybe do that overhaul. But that's one of the things you can get a good hint at here. And also you can tell the other way around if the engine is actually doing quite well. Well, maybe you could delay, of course, depending on what your engine manufacturer allows you to do. Looking at a different view of sort of the same data, we can see some of the raw values coming in here, which are the cylinder temperatures, which is one of the things that we are looking at to profile the engine to see how it's doing. And in the end, actually, the final engine profile is then something that we can use as well to figure out how much we can actually push the engine, how much work it can do safely. So there's that. So doing the engine profiling is quite useful. But that's part of the whole predictive maintenance suite that we've been developing on top of the data that we collect on the vessels. So there's that. Let's see now, we can move on to, so going into the specifics of the model that we are using on the vessel. So what is that all about? Because the core product that we've been delivering for the past 3-4 years or something like that at this point is the Frugal Propulsion setup that goes on the vessel. And that's also based on a model built from the data we collect on the vessel. And what does it do then? Well, it figures out how to best run your engine and propeller together to get the best fuel efficiency and the best propulsion efficiency. This is, of course, mainly concerning the controllable pitch propeller vessels, but we also have features for fixed pitch propellers. This, what we're talking about today, is mainly for the controllable pitch propeller vessels. But what we can do here is we can figure out, well, if we build a combination of engine RPMs and the propeller pitch, we can make sure that this combination is within the safe limits of what the engine can do. And we can also make sure that that particular combination is the one that gives you the best specific fuel oil consumption, and at the same time gives you the best propulsion efficiency. So that is the grams of fuel per kilowatt hour you are generating, and also the kilos per nautical mile that you are burning to basically just move ahead. And interestingly, in this particular case, this is data also coming from one of the vessels that we've been running on. You can see for the blue curve, that's actually the propeller curve that came with the vessel. So this is the one that was built into the power handler on the bridge when the vessel left the yard. And it looks like propeller curves quite often do. It's sort of a stepwise thing where you can see when you're running at up to 150 RPMs, you can only add 65% pitch. If you run at somewhat higher, you get to add a bit more, and so on in steps. But when you compare that to how our propeller curve looks, there's quite a bit of difference. We can add quite a bit more pitch at an earlier point because we actually know how things are doing and what the actual performance of the vessel is like at this point. Whereas the blue static curve would have to take into consideration how things were at day 0 when the vessel was completely new, but it will also have to work at maybe 20 years into the future when everything might be in a considerably worse condition, that you couldn't possibly know about at the design time. So that's why the blue curve it looks the way it does. It's not that it's bad curve, it's just that it has to be cognizant of the fact that a vessel gets quite old and you don't know exactly what the condition might be 20 years down the road. But we do, because we actually monitor the condition. And then the green curve shows what the vessel can be made to do when everything is nice and clean. And then you can see the yellow curve where we have to over time back off a little bit, because we can tell that the engine is maybe getting a little bit foul. Maybe we're getting closer to the time where the overhaul should be due, and then we'll need to take a little bit off. But the main point is that at any time, Frugal Propulsion is actually ensuring that the performance is as good as it gets under the conditions that you're actually looking at. And the whole flow of data is very much as it is in any other data solution, that we collect the data. You can see this on the blue circular diagram out here, that we can collect the data continuously. We send the data back to our cloud solution. We generate propeller curves. And if we find one that's better than the one we already deployed, then we send it back to the vessel. The crew uses our system, which we'll get to in a bit. RPM and pitch are then changed according to our propeller curve, and so on and so on. We collect the data again and improve as we go along. Now, in the whole setup of things, the components that we put on the vessel are placed in a couple of locations on the vessel. So one thing is that we have an electronics cabinet that has all the integration points with the existing remote control system on board, because it's important to note here that our system doesn't really replace any components on board. We interface with the existing propulsion control system or remote control system, whatever you want to call it, which might be from MAN or Lyngsø or Wärtsilä or Kongsberg or any of the others that we've done projects with at this point. So that we have a clean official interface between us and the underlying control system, such that all safety systems remain in place, and there's no change to the way the engine is being operated safety-wise, and same goes for the propeller. And then on top of that, on the bridge, we have our bridge panel, which is basically, you could liken it, well, actually completely, to an additional power handle. With the only difference being that when you use our panel, our thrust handle, then you're automatically using the latest and greatest in propeller curves that matches this particular vessel. And then you get some savings on top of that, which is pretty great. And then on the very top of that, at home for the operations crew, you get the fleet management solution where you can see the predictive maintenance results and so on and so forth. So that's the package you get. And again, it continuously improves or detracts a little bit from performance, depending on what you can actually get away with on the equipment on board and the condition of it. And just to zoom in a little bit, when you use the bridge display solution, you also have a couple of built-in niceties, which is you get speed piloting, so you can keep a set speed using our system. So if you want to maintain, say, 12.5 knots or whatever, we can ensure that that actually happens when our system is in control. Same goes for output power on the main shaft, or which is basically the same as fuel consumption. If you want a fixed consumption, we can also make sure that that happens. All while using the optimized propeller curve. So you get the speed you want, or the fuel consumption you want, at the best possible efficiency. So that's pretty good. And the electronics cabinet, again, in the ECR, you have sort of a grayed out view of it here. It's maybe not so important what it looks like, but again, it gets the integration points with the propulsion control solution, all the sensors that we need, which is not that many, but the core of what we want is things like fuel consumption, torque on the main shaft, GPS, lock speed, those critical parameters. So yeah, that's the package. And then what? You might ask, what are the results here? We actually tried doing a different kind of plot from what we usually do here. We tried to do a distribution of, well, the vessels that we have distributed by age. You can see here down along the bottom, you see the vessel age, and then the blue dots represent the count of vessels we have at a particular age, and then the number on top is the savings that we achieved on average for that particular year. So the savings are pretty good, and so the age of vessels that we are looking at goes from quite old. 1996 is definitely not the latest edition, and all the way up to 2017 for the very newest one. And you can maybe obviously there are some wholesome years that don't have any vessels from, but you could sort of see a trend, maybe a slight downward trend, such that newer vessels save a little less, which is not too surprising given that designs improve. It would seem reasonable that if you have a new vessel, you would expect it to be more efficient, which it seems they are. But also interestingly, you can see that for the very last vessel from 2017, the savings are quite significant. It's 15%. It's one of our very best ones. But that happens to be because it is a new vessel, but it's based on old drawings. So the actual project that this vessel was built on is 20 years old or something like that. So you're looking at a new vessel that's 20 years old in a sense. So that's why it's actually not so much better than the older vessels. But that happens a lot. You see new vessels that are built on old designs all the time. But critically also, new designs are getting better. Interesting. That's the stuff we see here. And that pretty much puts us through the set of slides that I wanted to show you about Frugal Propulsion and our cooperation with Emerson. So thank you very much.
Oh, very good, Lars. Okay, so if you want to stop the slide stream, and then we'll open to questions. If there's a couple of questions coming in, and I've got a few of my own. I mean, just
Sure.
to start with on this controllable pitch propeller, because when I just asked Google, it said that 20,000 vessels in the world have CPP, which I don't know if that's all what kind of vessels, but it's sort of half. It's about half of all vessels have this, but they're not used as much.
I would say it's not quite half. I would say I think one of the counts that we're looking at is saying that there's about 100,000 vessels total out there, and about 30,000 of them maybe have controllable pitch propellers. So it's a good solid share of them. The very largest of vessels don't have controllable pitch propellers because the physics of it just makes it difficult to make propellers that can actually be pitched. So there's that. So smaller vessels that need the maneuverability you get from it have controllable pitch propellers. And then actually just to tie into that, you can say that the features that we do have for the fixed pitch propellers are still quite interesting because we still have the predictive maintenance features. We still have the power piloting and the cruise control. So we are still able to do sort of the behavior-based savings on those vessels as well. I didn't include those in the numbers we have here today, but they're still very interesting. And we have a number, 5 or 6, I think it is, vessels running our system on fixed pitch as well.
Oh, but the basic logic, so the pitch of the propeller is like the angle of the blades, and that's
yes, exactly.
The best angle is different depending on the speed you have, and that's what the propeller curve shows.
That's basics of it, and then you also get some interesting optimization options because it also depends on how far into the water you push the hull, because sort of the propeller efficiency changes quite a bit with the draft of the vessel. So that's one of the other parameters you have to keep track of as well. So a loaded vessel performs quite a bit differently from a ballasted vessel, for instance.
Oh, very good. Okay, so if you'd like to open the Q&A box, we'll have a look at the. We've got 3 questions here. Sure. Giulio Gennaro, he worked with a Core Power doing nuclear power on ships, and he's also a maritime consultant in Singapore. But he's asking, first of all, what is the logic for AI to clean the data? So I think you said you had NVIDIA's engine which implies
we use that. So it's in a sense, it's a quite classical recursive RNN, recursive neural network model that we are using. So we're using sort of the NVIDIA tool stack or the Open Compute also tool stack to do this. It's nothing too special in the whole cleaning. So I guess the most important thing here is to be able to apply those technologies correctly to the data you collect. But in that sense, it's nothing too special in that way, the cleaning of it. But it is putting a lot of effort into it for anyone out there wanting to do anything with data. That really, it's like saying that you have your product division and your sales division, and they have to be 50-50 for a company to really want. Same here, cleaning 50% and then model on top of that. It's really important.
Oh, yeah, because you have that graph of the data going all over the place. I couldn't actually pick out any anomalies in that graph because it wasn't
No,
obvious.
yeah, no, because it can be hard to tell. There's one thing is data that's actually anomalous, and then there's the other thing, which is regular noise. The signals change. Let's say if it's a shaft power and you have waves impacting the vessel, that's not an anomaly. That's just some noise that you have to be able to subtract. Anomalies would be things like the sensor perhaps behaving not quite as it should be, and you need to get rid of that. That's common, for instance, for speed logs, the sensors that track vessel speed through the water. They have quite a few anomalies, but you can clean it up, and then it's a very good sensor.
Wow, very good. Maybe you'll bring Naveen into the discussion. So a question crossed my mind. So Emerson's obviously a big company, and this service is quite labor intensive, which I guess big companies normally like automated or process solutions rather than stuff that depend a lot on people. But you've obviously chosen to invest in Frugals. Is that something you've want to share some thoughts about?
Sure, Carl. I think one of the reasons when we were looking at how do we expand our portfolio was how do we serve our customers better? I think that was the main intention. And then we kind of connected. We actually did a survey where we looked at different stakeholders. These are the ship owners, the charterers, shipbuilders, some of the classification society, and also some of these third-party OEMs who are there. And I think all of it connected to what is happening in the industry. The data is there. How do we make use of it and have a closed loop system? And we were also thinking at how do we make it easy for the customer. So as I mentioned before, I mean, if we have a technology, we cannot wait for the dry dock to come in and then we implement it. This should be something which can be implemented as easy and can also start reaping the benefits as quickly as possible. And Frugal came into the picture, and it was actually ticking all the boxes. Of course, this was also a marriage because we didn't have the product, and Frugal also is a company based out of Europe. And we are a global company, Europe, US, Asia as well. So we cover we have offices everywhere. So with the broad sales and the service and the project execution setup, I think this is something which we can expand quite a lot. And I think ultimate aim is to basically how do we bring the benefit and solve the pain of the customers.
Oh, very good. Well, we've got 4 quite technical questions now, so we're going back to last. By the look of it, I think first we'll go to Timothy Belorusov, whose LinkedIn says he's in Armenia, chief data analyst with Ocean Lee, optimal frequency of data collection. So this is a problem which comes up an enormous amount of times in our webinars. It might sound simple, but so he's saying is 5 minutes enough? I think you said you thought 1 minute was ideal, but
it's a very good question because it depends very much on what you actually want to do with the data. But for our purposes, 1 minute seems to be a good sort of value to use, and so we basically downsample the data that we collect from. Actually, on the vessel, we collect data every 5 seconds, but then we downsample that to once a minute, and then that's what we actually send home to the data store, and that works very well for us. But again, as I think I briefly mentioned, you can still get quite interesting results from just looking at noon reports. So that's just once per 24 hours. But obviously, you won't be able to do the sort of optimization that we're doing. Doesn't mean you can't do anything. You can still track a lot of health parameters just by looking at noon report. So it depends very much on what you want to achieve with the data you collect. That's I guess maybe that's not super helpful as an answer. I mean, people would like to get you should do it once a minute, and then that's great. But it's a good place to start an analysis. How much data do you actually need?
Yeah, thinking it through, I think, yeah. So if we go to Rama Krishnan, who's a health, safety, environment, quality superintendent with executive ship management in India, he's saying he'd like to have a sort of dashboard on the bridge which tells you what the CII is at any time. So
oh yeah, that's actually it doesn't do it right now, but it will do in October. Then we'll have a new set of features coming out that actually shows the instant CII. We do get the CII on your office view. So if you're sitting at home in the operations department, then you can actually see it. But not yet on the vessel. But come October, you will be able to.
Wow, I mean that's quite computation because CII is an annual score, isn't it? But I guess you're saying you'll see where you are.
You can calculate it instantaneously because it is basically just how much stuff are you carrying versus how much fuel are you burning. So you can do sort of an instantaneous evaluation of it. to see if you're running off the track completely or if you're sort of in the ballpark, which can be quite useful.
Oh, very good. So Nikos Sophios is a performance engineer with Ocean Gold tankers in Greece. Do the crew have to do anything, or is it collected automatically from sensors? I suppose it depends what sensors you have. I don't know.
Yeah, but we're quite adamant about making sure that we can do the collection automatically. Also, the collection of sensors that we need is not that big. We use the GPS, the speed log, the AIS, and then fuel sensors and torque sensor. That gets us very far along the way. If we have access to the alarm system, then we can get the rest of the values we want that way around. But again, that's totally automated. So no, the crew doesn't have to be involved in anything.
Yeah, Naveen, you're an ex-seafarer and you work in automation, so it's a very rare combination in this world, I think. But what do you think is the best way to set things up on board ships to make it easier for crew? Is that, I guess, that must be something Emerson thinks about a lot, isn't it? I don't know.
Yeah, I think as a seafarer, I think the main thing which I would say there's a lot of work on board the vessel. I mean, it's a 24/7 job throughout the year. So if we can simplify the work, the reporting, and also some of these systems on board where the automation is involved, I think that helps a lot. There's a lot of job which is transferred from the onboard the vessel to the shore. So I think that is what I would say it helps a lot through this system.
Oh, very good. So if we go to Adamantia Apiranditi, who's a data analyst with TMS tankers, probably in Greece. So which is asking you, Lars, about your terminology by the look of it. We're going to call it deep learning or machine learning if it's just data cleansing. But I don't know if there's any deep learning in there. Was there? I mean,
there is. It's just when you say deep learning, people quite often associate it with the large language models of ChatGPT and things like that. And our models are nothing of that size. We don't need anything like that. The amount of parameters we're looking at is far less. But it is actually the same sort of software that we're looking at. So is deep learning or machine learning more accurate for data cleansing? Well, you can certainly do it using classical programming as well. But the great thing about this is that there's so many tools out there at this point that are tested by at this point I would say tens of thousands of people. So the quality of the components you can get if you use these deep learning technologies is very, very good. And then if you use the accelerated hardware, you can churn in ridiculous amounts of data very quickly. So those are the benefits. It's mostly volume, and then quality of the components that you get to use is very big. It's surprisingly good at this point.
Oh, very good. So if we go to Ramakrishnan in executive ship management, how do we know that the vessel is performing optimally? Is it compared with the sea trials or the past performance of the vessel based on data collected over a period of time? Or
yeah, that's a very good. That's a very good question. So looking at our engine performance view, for instance, that's actually based on some previous data. So we have a window of time that we've that we define as baseline. That's typically 3 months of data, and then we compare to that. So we can predict how the engine would perform based on that data, and then we can see sort of the deviation from that. That's the interesting part. But ideally, of course, it would be nice to have 3 months of data immediately after a yard stay, for instance, where the engine has been overhauled. So you have the super duper nice baseline to compare with. But as long as you have some sort of baseline and you can see how are we doing, is it getting better, is it getting worse, it's very useful. And then we're also able to label a particular period as, for instance, immediately after a yard stay. So you can tell what kind of baseline we're looking at.
Yeah, and I guess it's one thing for a data analyst to work it out, but another thing for a senior manager to work it out. I don't know, is there sort of dashboards or something like that that
Yeah, it's we try to make them as accessible as possible, the whole dashboard thing, to look at what's going on and to turn it into simple, just as few numbers as possible. So basically, as I just I think I showed that off just a bit previously, you get an actual dollar value or approximate dollar value per day that you are losing because of, for instance, engine fouling, things like that. So that's a simple value that you get that you can actually use as an actionable KPI.
Well, very good. So we've got 2 questions about weather now. So Giulio Gennaro from who's the consultant in Singapore is saying, how are you measuring sea state and because it's got a major influence on the performance. Prashant
Yes.
Biradar with Smart Ship Hub in India is asking, so how do you identify if you've got an outlier? It could be because of bad weather or something wrong with the machinery. So.
Now then, okay, so let's maybe do the weather first. So our model, the way we generate the propeller curves is sort of done retroactively. We collect data and then we look at it after. So we're not doing things, it's not a live optimization, you could say. And that gives us the opportunity to use other services to collect weather data. So we're actually using on some of the, there's a service called Stormglass, for instance, that provides weather data that's quite good for not all of the planet, but a very large part of the planet. And that's actually the data we use. So we sort of superimpose the weather data that we get from those services on the data that we've collected ourselves. And then using the deep learning, actually, we can subtract weather effects from the data. And that also ties into how we identify the actual outliers. Again, that's some of the deep learning models that are able to actually do this quite efficiently, if you're able to add the weather data as well, because otherwise it's very difficult to say what is an anomaly and what's not. But if you have both the measured data from the vessel and the weather data, it becomes possible to actually figure out what's what. So that's how we do it.
Yeah, you've got a lot of questions about digital analysis. Yeah, haven't we?
Oh, that's a good one there. This how do we prevent overfitting? We had so much trouble with that in the beginning. The core of overfitting is that when you do your model and you sample data from the running setup that's been based on your model, then the sort of window of opportunity shrinks and shrinks and shrinks, and at some point you're not really learning anything new. You're just sort of fiddling around in a little box that you've made yourself, so to speak. That's about it. But what we do is we use sort of what you call it sort of fuzzy tuning, where you try to add a little bit here, a little bit there, to a random amount of pitch, small amount, of course, to the propeller, to see, did that improve things? And then maybe we can wiggle into a new area of performance if that actually made a difference. And if it didn't, well, then we'll stop doing it. So that's actually how we do it. So fuzzy tuning, I guess, is the short answer.
So how are the crew? Are they going to follow your instructions? Are they, or how does that work?
No, they don't have to do anything. As long as they use our HMI panel on the bridge, they're automatically using the latest in optimization that we've deployed on the vessel. And then this particular fuzzy tuning is such a small amount that it doesn't really impact performance to any measurable, yes, degree, but not something that really impacts speed significantly. So we don't want to try out all sorts of strange and random settings that would all of a sudden impact speed. So it's small changes that we do to see if we can do something better.
Oh, very good. So Krishna is an independent chief engineer and consultant in India. And the next question, Timos Boompulis is a senior software architect with Starbulk in Greece. So how do you detect if the hull is fouled?
Yes, that's also a good question. So that we can detect simply by looking at the vessel's speed through water, and then at the same time the power output in relation to the draft of the vessel, because then we can see if we're starting to have to push harder to make the vessel go at some speed. Probably we're dragging something along with us. So that's sort of the basics of it. But there's a feature in the online platform that also gives you a good indication of the losses due to hull fouling.
Oh, and a question in my mind, how this can all work operationally, because it seems like very, very labor intensive. I mean, Lars, you've obviously worked in this field for a long time, and it looks like you did a lot of work, perhaps personally, on these projects, or perhaps you have a team of people.
Quite a bit. Yeah, but we have a team of people now, so we're what, 7 developers total now.
Right. Well, they're developers, they're not modelers. So the software does the model.
It's software developers, but with quite specialized in data science, I would say.
Wow, and we can see a lot of shipping companies are employing more and more data analysts and performance managers. We see them on the webinar now, but this is the future, I suppose. So you've got like a big companies like Emerson, plus teams of developers, plus companies having their own teams of specialists. So.
And I think it's also quite interesting that it sort of mirrors what you got on factories and all sorts of land-based industries. some years ago with the business intelligence things back then, as I think I also briefly mentioned, were quite a bit easier because you don't have all the weather effects to contend with on a factory, for instance. But collecting data and sort of mining it for something interesting, it's sort of the same thing we're seeing here. And now that the technologies are in place, you can actually do it and handle it, even though we have all those additional factors that you have to contend with when things are actually sailing.
Oh, so Naveen, do you think Emerson's ready for a future where companies have their own data scientists using your tools to work out how to do things better, or is that the way you think?
I think one of the reasons for collaboration was like some of the oil majors and the big shipping companies, they've started employing people who are looking at the data and make sense out of it. And we gave a lot of data from our side on the flow meter, on the other machineries which are there. But how do we make the end result out of that data? So that was always a question. Of course, Emerson as a company, we do have a big team who are looking at the data, making sense of it, and we wanted to do something similar in the marine. And marine is a little bit niche in the sense the vessels has controllable factors which can be controlled, like what Lars mentioned, and there are also something which are uncontrollable. So it's a floating thing which is different from what we have on the land. And I think that is where this collaboration becomes important, because we have some of the technology which is there, but we also need some capability on the data science, which Frugal comes in with. So it's something which we are looking forward to also developing and increasing the scope in future. It won't be just sticking to the flow meter part of it or fuel efficiency. Maybe we'll do more with the help of Frugal team.
Oh, yeah, we've got
We
a question.
definitely want to do that. That's for sure.
Yeah, so it's another question. Prashant Barada with Smart Ship Management in India. So how can you tell if the resistance is because of the propeller or because of hull fouling?
Oh, that's actually a very good question as well. Actually, that I'm running into. I'm owing you an answer there, but the other developers are looking into doing exactly that. Again, we're looking at what happens when the engine RPMs increase. How does that impact the propulsion efficiency? And that also, in relation to still the log speed, it lets us divide the two, but we still don't have that feature ready. There will be a feature coming for the online platform as well, that allows us to identify how much is going on with the propeller, how much is going on with the hull. At this point, we're showing them as a sort of aggregate.
Oh, no, that's great. And just a question from me, I mean, on your customers, Lars, so I don't know how much you're able to say, but I mean, you showed that slide, I think I counted about 30 ships at different ages.
So 40, I think there are 48 on that particular slide, yes.
So there's 48 ships you're providing services for now. So I don't know if you want to say any more about them.
A bit more, actually. We have +6 fixed pitch propeller vessels that are not counted on those slides. So 50 some we're looking at, with quite a few more in the pipeline. I would say you were asking. Sorry, could you repeat it? You were asking me something specific.
Well, what you're able to say in public about the customers? I think the audience would like to know. Yeah.
So it's a wide range of customers. It's sort of all fields, I would say. We have tankers, bulk carriers, container vessels, all that sort of thing, varying sizes. I would say the customers that we have are quite happy with the solution that we have at this point. Some of them have been very patient with us because they've been with us from the very get-go when our product wasn't very good. But at this point, everything has been tuned based on their input. And one of the things that they're quite happy about is the simplicity of it. So again, that you get a panel on the bridge, which is quite basically an extra power handle, and you use it, and then that's it. You get savings. So that helps a lot. That's happy, and that's a happy company, it's a happy crew, because it's not something super complicated they have to take into account. Typically, nobody wants to look at a very complicated new product on board, because, as Naveen says, the crew is busy. They're always busy. So keep it simple, and that's what we've been trying to do. And also the installation process has we get good feedback on that, because we are able to do it quite quickly. So a longish port stay is enough for us to get the whole thing running. So that's pretty good.
Oh, very good. We're coming to the end. Perhaps we'll pass the word back to Naveen now. I mean, what should customers do if they're looking to if they think this is a good idea and they want to work with you, or what kind of customers are you looking for? Maybe in your course of your answer, you'd like to answer Timos's question about can you see the webinar materials? I think we said probably yes, but we're going to check. Is it? I don't know.
Yeah, sure, Carl. I think we can be reached out, me and Lars can be reached out by anybody who's looking at more information or just having a discussion on how the technology works. We are very open. And I think as Lars mentioned, we have quite a few data on the CPP where the saving is around 15%. So, I mean, it's the system is proven, it's working very well on the CPP. And I think one of the highest returns which we are looking at. But also, I think as I see, there might be some people who are also might have a question on the FPP. I would say the system is working very much in a similar way for FPP as well. Of course, the things which can be controlled are less because it's only the RPM which can be controlled. There's no pitch. But in terms of the saving, I think absolute number is equally high because the consumption is much more. So when we look at some of these ROI calculation, the FPP also are really, really strong where we see. It's just that we are just working on with few of the customers where we need to kind of have those numbers in. But I think equally good saving, which we look at the FPP along with the CPP vessels, which we see here.
So it says you're really good at 65 RPM is a very good RPM if you're going to 10 knots, but not 64 RPM or something like that, and that makes a huge difference to the fuel consumption.
No, that's about it. The main thing we're trying to avoid on the FP, well, on all vessels, but what we can do in particular for the fixed pitch vessels is that you want to avoid overconsumption by going too fast, for instance, and you want to make sure that if you have a charter that dictates a particular consumption per day, that you actually stay at that consumption. So it's mainly sort of a fine-tuned behavior that we are optimizing on those. And as Naveen says, it's true that in dollars and cents, the savings are still very good. It doesn't look as impressive in percent because maybe it's 3-4% or something like that you can find on a fixed pitch. But then if the vessel is burning maybe 40, 50, 60, 70 tons per day, that's still quite a bit. And where many of the controllable pitch vessels might burn only around maybe a maximum of 20 tons. So 15% of 20 tons is quite a lot, but 3% of 60 tons is definitely also a lot. So yeah, in dollars and cents, still very good.
Yeah, that's great. Well, I think it's a great story about how you use human expertise together with digital tools. I think it shows the way the future is going to be. So mixture of experts, mixture of digital tools, mixture of big companies and small companies. But no, I didn't see any solutions, which is good. You know, when people promise the whole earth in a presentation, we sometimes hear, and it's almost much harder than that, isn't it? But with the right kind of systems, we can get there. But if you'd like to take a couple of minutes each, perhaps to wrap up, maybe Lars and then Naveen, is there any last words you'd leave the audience with before we finish?
Well, I mean, one of the things we're very happy about here is also the cooperation with Emerson, because where we were before we teamed up with Emerson, we were looking at figuring out how to service customers all around the world, and how would we even go about that? Would we start our own offices in wherever? We didn't even know how to do that. There was no way. We were kind of getting stumped at that, and also the access to technologies that we really wanted to use. It's harder for a small company to get, but at this point, working together with Emerson, we're making very good headway into some of the new stuff that we want to do as well, and we feel quite safe in thinking that we can actually service customers anywhere at this point, which is new to us, and that's great. That's really great.
Yeah, got a question.
Yeah.
Sorry. Question just come in. Derwin Tang. So LinkedIn says he's manager compliance and innovation with MISC in Singapore. If that's the same Derwin Tang, but he's asking about the shaft power
limitation. Yes. Yeah. So we actually have shaft power limitation integrated into Frugal Propulsion. So if I would imagine that most people already have this in some way or another on board, they would either have EPL or engine power limitation or a shaft pulley solution already in place. But if you don't, then you can use ours for that. And if you have some other shaft power limitation solution or engine power limitation, well, then our system incorporates nicely with that. There's no real issue in doing that. The propeller curves that we do are just laid out according to whatever the power cap is for that particular vessel.
Something else to add to the algorithm then. Yeah. Yeah, very good. Naveen, have any last words you'd like to share with people before we finish?
Sure, Carl. I think one thing which I want to highlight is and with this system, why like Emerson is kind of working with Frugal is when we look at the ESTs, once we install it, I think the savings keeps on decreasing once we keep on using it till the time dry dock. But the beauty of this technology is that it keeps on improving. It's something as we get more data, more would be the saving. So I think that is a really important point we were looking at as Emerson when we're looking at different options. So I think it's a proven solution. It's not something which is started off yesterday. It's a proven solution. Many installation exist, different type of vessel, different engine size, and different age of the vessel. So, and also in future, I think we see this solution developing in something more where we can add more value in terms of the data. That is what we are actually looking at. So I think we are really, really looking forward to this cooperation and collaboration with Frugal.
Well, thanks very much. Well, I think that's the end of the webinar. So thank you very much for Lars and Naveen. That's great. So our next webinar is going to be on 25th, which is next Tuesday, on understanding GMDSS regulations and how to remain SOLAS compliant from Cobham Satcom. So maybe we'll see you there. But thank you very much, Lars and Naveen, and we'll see you soon. Thank you. Cheers. Bye-bye.
Bye-bye.
Thank you, Carl.